Okay, let's move on to Professor Truel Hyde, who's presenting a paper for a group with the broad title of Dusty Physics on the Moon, on the Surface of the Moon. Professor Hyde.
Hi, Brad. Yeah, so I like to mention that True Hyde is not available today. So I'm going to introduce this presentation on behalf of True. Okay, so thank you, Brad, for the introduction. So my name is Toshi Hirobayashi. I'm going to introduce this study on behalf of True Hyde, who is not available today. Um, our work is supported by NASA BPS and a game-changing development program of NASA STMD under contract of JPL. This is a part of a preliminary survey of dust physics over the lunar science. So this is still like a preliminary, but I like to introduce that. Could you go to the next slide, please? So the lunar surface is covered with fine dust particles. Particularly the size of such particles range from microns to nanometers. Major processes generating such particles include meteorite impacts and thermal fractures and other processes. Next slide, please. So Xu Wang introduced a very great summary of the very complex behavior of the dust behavior on the moon, but I like to review a little bit. So the dust behavior on the moon is very complex, particularly due to complex lunar environment. The behavior may change depending on the day side and the night side, and also the size, composition, and the shape highly likely depending on or controlling their electrostatic properties. If there is a magnetic field, then the situation is more different because dust particles may experience different forces. Next slide, please. So we realized that it is very important to characterize the dust particle properties. Particularly, we considered shape, size, and composition are critical parameters to control their electrostatic behaviors. And also, those are highly affected by and coupled with lunar environment. Next slide, please. So this is a preliminary concept study that we have done, and we have been analyzing an instrument to measure a dust particle's mass, charge, and shape. Definitely, this is similar to what Xu Wang introduced, but I'd like to introduce a little bit more here on our team. So on the right, I'm showing one-dimensional schematic. It includes two different sections. First one is a charge measurement on the top, and then the second one is a mass measurement at the bottom. So for the charge measurement, it includes a grids or grid system that includes multiple grids to measure the charges. Does the particle go through it? And then when they enter the mass measurement section, then the mass measurement section includes electric field. So the particles are decelerated and then eventually captured by this section. Next slide, please. We are currently considering a three-dimensional CAD model. Certainly, we have some missing elements, but this is what it looks like. The first upper layer includes grid system. There are multiple layer grids. So by passing through the grids, the grid system measures the mirror current when particle goes through these grid system. And then the particles go through it, and then eventually it reaches the mass measurement section, which is empty right now, but we are currently designing potential devices to create electric field. And then confinement, this is a layer electrode, which is currently having curvature. This is because we want to emphasize that electric field to capture dust particles. Next slide, please. So the idea was that by this instrument, we would like to capture dust particles. However, a question is, can the instrument actually capture dust particles in the mass measurement section by using electric field? The answer is yes, for small particles. In order to show this, I show a simple plot showing voltage necessary to create electric field to capture dust particles as a function of particle velocity. So I'm showing here just three different particle sizes. Blue is 1 micron, yellow is 100 nanometers, and then green is 10 nanometers. If you look at the blue, which is 1 micron, as you can see, voltage actually goes to 10,000 volts, which would be a little bit challenging to create it in the in situ instrument. However, if we consider 100 micron, then the voltage is just tens of volts. So it could be reasonable to consider. Next slide, please. Another question is, how often can the instrument experiencing such capturing events? Or what kind of events we expect? The answer is, first of all, about the frequency, very often. And then what kind of processes is meteoroid impact secondary events? By impact secondary events, I mean processes, impact processes driven by ejecta from primary meteoroid impacts. We consider potential events, and there are 4 events that actually transport dust particles to instruments. First one, meteoroid impacts. This is a pretty much random process over the lunar surface. However, the frequency is actually limited. On the other hand, if we consider secondary impact events, this is promising, and I'm gonna discuss this in the next slide. Go to electrostatic dust levitation and lofting. This is a very exciting problem, which has been studied a lot these days. However, I would like to define this as sort of like a challenging problem to be predicted. So given that, I'd like to mention there is a risk that we cannot encounter such processes because of the uncertainties of particle properties or surface properties. I want to mention about the geological mass wasting, for example, landslides. may also bring particles to instrument. However, again, it is hard to predict, so I cannot ignore a risk. Next slide, please.
5 minutes.
Thank you. So by frequency of dust capturing events, what exactly means? I'd like to focus on the secondary events here. In order to discuss the frequency of such events, I'd like to define the frequency in this slide. By frequency, I mean the number of dust capturing events by instrument when the instrument is located anywhere on the moon. So like randomly placed on the moon. And then if the frequency is higher than 1, that means the instrument should experience dust capturing event at least once when the instrument is located anywhere on the moon. So if you consider frequency is less than 1, there is a risk that says, okay, you may not be able to get a dust capturing event. I'm showing here, there are 2 cases. The left side shows the secondary events with a size larger than 1 meter. In this case, I am showing here 3 different mission time periods, okay? And then I'm showing this as a function of particle velocity. If you consider these 3 cases, 0.1 years, 1 year, and 10 years, all the cases have frequencies less than 1. That says, okay, it might be a little bit hard to predict the instrument may have dust capturing events because the values are actually less than 1. However, if we consider secondary events with a size larger than 1 centimeters, which is given in the right side, the frequency is actually showing some promising value. I'm showing you 3 different mission periods. One is 0.01 years, second one is 0.1 years, and the last one is 1 year. So if you look at the 3 lines, those are crossing unity frequency around the velocity of 10 meter per sec. So we anticipate that dust capturing event may occur within this period for the particle velocities larger than, well, around 10 to 20 meter per sec. Particularly 0.01 year case is very critical. The reason is this is actually 3 to 4 days. So we can imply that dust capturing event actually occurs every 3 to 4 days. Next slide, please. So this is a summary. We are currently designing an instrument to measure a dust particle's charge, mass, and shape. And then the device consists of a charge measurement section and mass measurement section. It may be able to decelerate particles of hundreds of nanometers in size completely within a 20 centimeter length mass measurement section having tens of volts. Finally, the instrument can obtain dust capturing events higher than a velocity higher than 20 meter per sec every 3 to 4 days given small secondary events. Thank you so much. And this is definitely a preliminary assessment. So any advice would be appreciated. By this, I end my talk and I'll take questions.